So this video goes along with the trigonometry unit on angle measure. Okay, specifically we're going to talk about radians and degrees today. Okay, so the only thing this video is going to cover is this first bullet point here, converting angles from radians to degrees and then from degrees back to radians. All right, so first thing with angle measure. In geometry we just talk about degrees, but in trigonometry we talk about both angle measures. We have to be able to deal with degrees, we have to be able to deal with radians. Okay, so let's define both of those first. So degrees, we know what angle degrees are. Let's talk about them in terms of full circular revolution, okay? You guys know a circle has 360 degrees of measure, okay? And 1 degree is 1/360th of that full revolution, okay? Now radians you haven't worked with before. Radians measure the same thing. They're the measurement of an angle, okay? But in radians, a full revolution is 2 times pi radians, okay? Well, 2 times pi is approximately 6.283 radians, okay? So a radian covers, or excuse me, 6.283 radians covers a full revolution around a circle, okay? If you think back to geometry, think about the circumference of a circle, we had these two formulas, C equals pi times the diameter, or circumference equals 2 times pi times the radius, okay? In the future, we're going to talk about what's called the unit circle. All right, and if the radius of a circle is 1 unit, then we've got 2 pi radians measuring that full circular revolution, okay? All right, so based on degrees, a full revolution we know is 360 degrees. A half revolution would be half that, or 180 degrees, okay? Radians, full revolution is 2 pi radians, okay? And the half revolution would be pi radians, okay? So what this tells us is 360 degrees is equal to 2 pi radians. 180 degrees, therefore, has to be equal to pi radians, okay? So we're going to use these two values, 180 degrees and pi radians, to build what we call conversion factors, okay? So because 180 degrees equals pi radians, we know the unit rate here, 1 radian, is equal to 180 over pi. Okay, and that's in degrees, okay? 1 degree, conversely, would be pi over 180 radians. And these two conversion factors, 180 over pi and pi over 180, is how we're going to convert between radians to degrees or degrees to radians, okay? So these are the two conversion factors you're going to use, okay? All right, so let's look at 60 degrees. We want to convert that to radians, all right? Well, I'm in degrees. Okay, I'm in degrees like here. I want to go to radians, so I'm going to multiply by pi over 180 degrees. Okay, so when I do that, the 60 and the 180 cancel out. They're both divisible by 60. Okay, that's going to leave a 3 in the denominator. Okay, notice the degrees cancel out there too, so it leaves us with a unit of radians. Okay, so 60 degrees therefore would be pi divided by this 3 that was left over here, radians. Okay, so anytime you see 60 degrees, you know it's equal to pi over 3 radians. Okay, let's express 315 degrees in terms of radians. So again, we're going from degrees to radians. We want to multiply by this conversion factor, pi over 180. Okay, again, 315 and 180, they both have a common factor. The largest common factor they have is 45. Okay, if we divide 315 by 45, we get 7. If we divide 180 by 45, we get 4. Okay, so that simplifies to 7. This simplifies to 4. Okay, my unit that's remaining is radians again. So 350 degrees is going to be 7 times pi, or 7 pi, divided by 4. So 7 pi over 4 radians. Okay, if we can, we're going to leave radian measure in terms of pi as often as possible. There are some that's not feasible, okay? But angles like 60 degrees and 315 degrees, they simplify easily in terms of pi, so we're going to leave them like that, okay? If you want to find the decimal measure here, you just divide pi by 3. You're going to get a number a little bit bigger than 1, like 1.04 something, 1.05 almost, okay? 7 pi over 4, we're pretty close to 6 radians there. Probably a little bit less than 6 radians, but you guys can convert those to decimals on your own time. Okay, now let's convert from radians to degrees. Okay, so pi over 6 in terms of radians, I'm going to use my conversion factor of 180 over pi, okay? So I've got pi in the numerator there in radians. I've got pi radians in the denominator. Well, those are going to cancel out, okay? So what that leaves me with is 180 degrees in the numerator over 6 in the denominator, which easily simplifies to 30 degrees, okay? So pi over 6 radians is equal to 30 degrees, okay? A little bit tougher, 3.75 radians. This is given in decimal form, not in terms of pi, okay? But it doesn't change anything. We're in radians. We want to go to degrees, so we're going to multiply by this conversion factor. 180 degrees over pi radians. So let's do that, okay? Radians are going to cancel out, just a little unit or dimensional analysis there, okay? So what that leaves me with, now this 3.75 is over and understood 1, so it's going to give me 3.75 times this 180 divided by pi. Okay, you're going to want to use your calculator. Always use the pi key on your calculator. Don't use 3.14 because you're going to create some rounding error there. So do 3.75 times 180 divided by, again, hit the pi button, and we get approximately 214.86 degrees, okay? So that's how you convert from degrees to radians and radians to degrees. Make sure you memorize those conversion factors because you're going to use those a lot.